Welcome to an instructional video for trigonometry. So for this video, we are going to learn how to solve for a missing angle. So the steps are listed here. The first step is to identify the angle you are wanting to find. Step 2, label the triangle from that angle. Step 3, identify the trig ratio to be used. Number 4, set up your equation. Number 5, solve. So just keep in mind here at the bottom, so again, you don't have to memorize what the trig ratios are. You have sine, cosine, and tangent. They're listed in your formula booklet. I just put a screenshot there at the bottom just as a reminder for us. So in this question, we have a diagram here on the right, and the questions ask us to find angle x and angle z. So here, if we look at the steps, identify the angle we're looking to find. So we want angle x. So then label the triangle from that angle. So if we have angle x right there, we know that the opposite side is right here. So that is opposite the angle. We know the hypotenuse is always across from the little 90-degree angle, which is denoted by the square, which means that the 12 is adjacent. It's the adjacent side to our angle x. So now identify the trig ratio to be used. So we have both the opposite and the adjacent side. So given our diagram down here, that's going to be tangent. So this is question A. So we're going to do tangent of x. So tangent of the angle is equal to opposite over adjacent. So our opposite in this one is 6. All over the adjacent, so the adjacent is 12. So tan of x is equal to 6 over 12, and this is just the ratio, but we want to find what the angle is. So in order to find what the angle is, we have to find the inverse of the tan inverse of 6 over 12. So that will be equal to angle x. We can call it, use this if we want. So angle x is equal to the inverse tangent of 6 over 12. So I'll try and put this on the screen here in the right-hand corner, how to do that on your calculator, because sometimes that can be confusing, but you have to click the second function on most calculators, and then you click on the tangent button, and that will give you the tan inverse. So when we do that, you are going to get 26.56 ... So in this question, let's just round that to the nearest, let's go to the nearest tenth of a degree, so 26.6 degrees. So again, also make sure that your calculator is in degree mode, otherwise you're going to get some really weird answers. So let's do the second one. So I'm just going to erase that. If you need to look at it again, you can just rewind the video. Now we have part B. So part B, it says find angle Z. So we will label our diagram a little differently as it relates to Z. So now the opposite side is the 12 and the adjacent side is the 6. And again, the hypotenuse never changes. It's just the opposite and adjacent that can flip-flop depending on whatever angle that you're using. Right? That's the part that I find a lot of students mix up and get confused about. So again, it's all based on the angle that you're using to help you solve the problem, where the opposite and adjacent are. So in this case, we have Z. Angle Z is what we're using, and the opposite side is over here. That's the 12. So now if we're doing angle Z, so again, we have the opposite and adjacent sides. So we are again using the tangent ratio. So we have the tangent of Z is equal to opposite, which is 12, over the adjacent, which is 6. Again, I put a little cross through the Z just so it doesn't get confused with a 2. And we do the same thing that we did in the last question. So in order to find angle Z, we have to take the inverse of 12 over 6. So you're doing the tan inverse of both sides. And then when we do that, we get 63.43 ... So we will round that to approximately 63.4 degrees if we round to the nearest tenth. And there you have it. So there we have calculated both angle X and angle Z. And again, keep in mind all the angles in a triangle must add up to 180 degrees. All right, let's look at a couple other questions as it relates to finding missing angles. As you probably would have noticed, everything that we did in that first part used the tangent ratio, and it's not always going to, we're not always going to be able to use the tangent ratio. So we're going to do the same process we did in on the last page. Let's use a different color here. So here it says find angle G. So here we label our angle G. And now, right, we don't have the opposite, we have the adjacent side, and we have the hypotenuse. So, what ratio is adjacent and hypotenuse? Because again, we have to use the ratio of the two side lengths that we're given in order to find the angle. So adjacent and hypotenuse is cosine. So in this question, we're going to use the cosine of G is equal to adjacent over hypotenuse, so 6 over 14. And then just like we did in the last question, we have to take the inverse cosine of both sides, and that will give us the angle of G is equal to the inverse cosine of 6 over 14. So again, we type that into the calculator, and we will get 64.623. So again, if we round that to the nearest tenth, we get 64.6 degrees. Okay, if we do part B, it says solve for angle H. So now we label the triangle slightly differently. We've got the H over here, which makes this the opposite side, makes this the adjacent. So again, they just switch, and this is the hypotenuse. So now, what do we have? We have the opposite and hypotenuse. So opposite and hypotenuse is sine. So then we have sine of H, because H is our angle, is equal to opposite over hypotenuse. So that's 6 over 14. At this point, we now know that angle H is going to equal the inverse of 6 over 14. The inverse sine of 6 over 14. So when we type that into our calculator, we are going to get that angle H is equal to approximately 25.376 ... So angle H, if we round to the nearest tenth, will be 25.4 degrees. Okay, and now finally, there are always going to be word problems because what we're doing, it relates to the real world. So we're just learning the foundation so that we can apply it to real world situations. So most times you're going to be given, well, you'll be given a paragraph with words or a short couple sentences. You have to read them, and you're going to have to draw at least one triangle, and then they'll ask you a question that you have to answer. So if we look at this, we have a support cable is anchored to the ground 5 meters from the base of a telephone pole. So here we have, this is the telephone pole. And then this is where, like, this is the ground here. And then this is where the support cable is anchored. So this is 5 meters. So the support cable is anchored to the ground 5 meters from the base of the telephone pole. So this is 5 meters. The cable is 19 meters long. So this is the telephone pole here. So the cable itself is over here. That's 19 meters. So it says, what angle to the nearest degree does the cable make with the ground? So that's going to be this angle right here. That's where the cable meets the ground. So we'll call that angle theta. So theta is just a variable that we can use to represent the angle. So now we have our angle. So let's just use a different color here. So in relation to this angle, this is the opposite side, this is the hypotenuse, and this is the adjacent side. So we know that we have the adjacent and hypotenuse, so that is cosine. So we can use the cosine of theta is equal to adjacent, which is 5, over the hypotenuse, which is 19. And then again, to find an angle, right, we know that's going to be the inverse cosine of 5 over 19. And when we do that, we get approximately 74.74 ... So in this question, we have to be careful. They ask what angle to the nearest degree. So that's going to be approximately 75 degrees, because 74.74 is closer to 75 than it is to 74. Hopefully that makes sense, and we'll see you in the next video.